Angels. Welcome to a new learning episode. This is Teacher Eliza, your grade 8 mathematics teacher. Before we start, kindly prepare the following: your Math 8 self-learning module, your pen and paper for note-taking or for writing your answers as we go through this discussion. And most importantly, find a place in your home where you feel most comfortable to study and learn. We are down to our last lesson for this quarter, which is the probability of simple events. At the end of this lesson, you are expected to find the probability of a simple event, illustrate an experimental probability and a theoretical probability, and solve problems involving probabilities of simple events. Before we start, let us first have a review on what you have learned on your previous lesson on counting the number of occurrences of an outcome in an experiment. You may write your answers or ask questions on the comment section below. For our first problem, a coffee shop offers these choices: 3 flavors of coffee, which are cappuccino, mocha, and latte. Sizes of coffee are small and large, and coffee may be hot or iced. In how many ways can you order your coffee? Use the fundamental counting principle to answer this problem. You have 10 seconds to answer this one. Are you done? If your answer is 12, then you are right. There are 12 ways in which you can order your coffee. Using the fundamental counting principle, we just have to determine each event and list their total number of elements, and their product will be the total number of possible outcomes. In this example, 3 multiplied by 2 multiplied by 2 is equal to 12. So there are 12 ways in which you can order your coffee. Next problem. Mary has 5 blouses, 4 skirts, and 2 pairs of sandals. How many different blouse, skirt, sandals outfits does she have? You have 10 seconds to answer this problem. The correct answer is Mary has 40 different blouse, skirt, sandals outfits. Using again the fundamental counting principle, 5 multiplied by 4 multiplied by 2 is equal to 40. Thus, Mary has 40 different blouse, skirt, sandals outfits. Remember that you may also use the other ways of counting the number of occurrences of an outcome in an experiment, which are the T-diagram, table, and systematic listing, and you will come up with the same answer. Great job, grade 8 learners! You did well on your previous lesson. I guess you are now ready to have our new lesson on the probability of simple events. Let us define first what a simple event is. A set of outcomes is called an event, while the set of all outcomes is called the sample space. In general, any subset of a sample space is called an event. A simple event is an event where all possible outcomes are equally likely to occur. So the probability of simple events will have all possible outcomes equally likely to happen. This likelihood can be expressed as a fraction, a decimal, or in percent, with 0 being the probability of an impossible event, and 1 or 100% for a sure or certain event. Let's have an example. In tossing a coin, the 2 possible outcomes are a head or a tail, and the probability of a head or a tail is equal. Thus, there is a 50% chance of getting a head or a tail. Similarly, when you roll a die, you can get any of the numbers 1, 2, 3, 4, 5, and 6. The chance of any of these numbers is equal to the others. Thus, it is equally likely to get any of these numbers. Another example is tossing a coin 50 times and record the outcome, heads or tails each time. And let us say heads occurred 28 times and tails occurred 22 times. According to this experiment, the probability of heads occurring is given as 28 over 50, and the probability of tails occurring is given as 22 over 50. This is an example of an experimental probability. Now let's get to know more about experimental probability. It is a probability derived from a series of trials or experiments. The probabilities obtained from an experimental probability may differ as we increase the number of trials. It is because the experimental probability of an event may vary from one experiment to the next. In this one, we can use the formula probability of an event is equal to the number of event occurrence divided by the total number of observations. On the other hand, we have the theoretical probability. It is the ratio of the total number of favorable outcomes and the total possible outcomes. It assumes ideal conditions and is determined through the same space. The theoretical probability of an event is given by probability of an event is equal to the number of favorable outcomes divided by the total number of outcomes, or P of E is equal to N of E divided by N of S, where N of E is the number of ways the event E can occur, and N of S is the total number of possible outcomes. And of course, the total number of possible outcomes is also the sample space. So, the main difference of the experimental and theoretical probability is that the experimental probability is the result of an actual experiment, while the theoretical probability is what is expected to happen. Let us now solve problems involving probability of simple events. For our first example, a committee has 8 females and 12 male members. What is the probability of choosing a female as the president of the committee? The probability of choosing a female president is equal to the number of favorable outcomes divided by the total number of outcomes. In this example, that number of favorable outcomes is the number of females, and the total number of outcomes is the number of all members. We have 8 females and a total of 20 members. Substitute this in our given formula, we have 8 over 20 or 2 over 5. Next example, the numbers 1 to 10 are written on separate pieces of paper, folded and put in a box. One number or piece of paper is drawn from this box. What is the probability that the number chosen randomly is 3? Our sample space consists of the following elements: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So N of S, or the total number of possible outcomes, is equal to 10. As you can see, there is only one number 3 in the box. So N of E, or the number of favorable outcome, is equal to 1. Substitute this in our given formula. B of E is equal to N of E divided by N of S. We have 1 over 10. Thus, the probability of choosing 3 is equal to 1 over 10. Next question from the same problem: what is the probability that this randomly chosen number is even? Again, our sample space consists of the numbers 1 to 10, and N of S is equal to 10. As you can see, we have here 5 even numbers, which are 2, 4, 6, 8, and 10. So N of E is equal to 5. Substitute this in our given formula. We have 5 over 10 or 1/2. So the probability of getting an even number is equal to 1/2. Next, what is the probability that the number chosen is a prime number? We have here 4 prime numbers, which are 2, 3, 5, and 7. So n of e is equal to 4. Again, substitute this in our given formula. We have 4 over 10 or 2 over 5. The probability of getting a prime number is equal to 2 over 5. Next problem, a bag has 3 green, 2 red, 5 purple, 10 white, and 5 black marbles. What is the probability of choosing a black marble? We have to get the total number of marbles in the bag and the total number of black marbles. The total number of marbles in the bag is 25, and the total number of black marbles is 5. Thus, n of s is equal to 25, or the number of possible outcomes is 25, and n of e, or the number of favorable outcomes, is 5. Thus, the probability of getting or choosing a black marble is equal to 5 over 25 or 1/5. Next, what is the chance of picking a red or green marble? The total number of red and green marbles is equal to 2 plus 3 or 5. Thus, n of e, or the number of favorable outcomes, is equal to 5. So, the probability of picking a red or green marble is equal to 5 over 25 or 1/5. Next question, what is the probability of choosing a brown marble? There are no brown marbles in the bag. Thus, the probability of choosing a brown marble is equal to 0 over 25 or 0. And last question for this problem, what is the probability of choosing any colored marble? There are 25 colored marbles in the bag. Therefore, n of e is also equal to 25. Thus, the probability of choosing any colored marble is equal to 25 over 25 or 1. Let's have another problem. Given a standard die, determine the probability for the following events when rolling the die one time. Letter A, P of 5, or the probability of getting a number 5. Letter B, the probability of getting an odd number. And letter C, P of 7, or the probability of getting a number 7. Let us first determine the sample space. It consists of the following elements: 1, 2, 3, 4, 5, and 6. Thus, we have a total of 6 possible outcomes. So, n of s is equal to 6. Let us have letter A. For letter A, we only have one number 5 in the list of all possible outcomes. Thus, n of e is equal to 1. So, the probability of getting a number 5 is equal to 1 over 6. Next, letter B, the probability of getting an odd number. We have here 3 odd numbers, which are 1, 3, and 5. So, n of e is equal to 3. Substitute this in the formula. We have 3 over 6 or 1/2. So, the probability of getting an odd number is equal to 1/2. And letter C, P of 7, there is no number 7 in a regular die. Therefore, the possibility or probability of getting a number 7 is equal to 0 over 6 or 0. Let us have our last problem. A card is drawn from a well-shuffled deck of cards. Find the probability of drawing the following events. Letter A, a king. Letter B, a heart. And letter C, not a king. An ordinary deck of cards consists of 52 cards. So n of s, or the total number of possible outcomes, is 52. Let us start with letter A, the probability of drawing a king. we will denote this event of getting a king as letter K. So P of K is equal to N of K divided by N of S. As we all know, in a deck of 52 cards, there are 4 kings. So N of K is equal to 4. Substitute this in our formula, we have 4 over 52 or 1 over 13. So P of K, or the probability of drawing a king, is equal to 1 over 13. Now let's have letter B, the probability of drawing a heart. In this event, we will denote it as letter H. So P of H is equal to N of H divided by N of S. There are 13 hearts in a deck of cards. So N of H is equal to 13. Substitute this in our formula. We have 13 over 52 or 1/4. So P of H, or the probability of drawing a heart, is equal to 1/4. And lastly, the probability of drawing not a king. There are 4 kings in an ordinary deck of cards. Hence, there are 48 cards left which are not kings. In this event, we will denote not a king as letter B. So P of B is equal to N of B divided by N of S. So as I have said, there are 48 cards left which are not kings. Therefore, N of B is equal to 48. So substitute this in our formula. We have 48 over 52 or 12 over 13. So the probability of drawing not a king is equal to 12 over 13. And that ends our lesson. Great job, grade 8 learners! Let us now practice and apply what you have learned from this lesson by answering the given activity. Number 1. A hat contains 32 marbles. Of them, 27 are red and 5 are green. If one marble is randomly selected out of this hat, what is the probability that this marble is red? Number 2. A card is drawn from an ordinary deck of playing cards. Find the probability of drawing each of the following events. Letter A, a queen. Letter B, a red card. And letter C, the king of spades. And that's all for today. Thank you for your time and effort. I hope you have learned a lot from this lesson. Again, this is Teacher Eliza May S. Cunanan, your grade 8 mathematics teacher. Have a good day and God bless.